Hello, my name is Sean Everest. I'm with the University of Arkansas Pulaski Technical College, and I will be your instructor for this portion of your training, the use of a machinist ruler to measure parts dimensions. When you finish this training, you will be able to inspect a rule for damage, read a rule, and measure parts using the rule. Machinist rules are the most common measurement tool used on the plant floor. Although they are not as precise as some other measurement devices, they are very useful for making quick measurements of machine parts. In this procedure, you will use a machinist rule to measure parts and compare their dimensions to an engineering drawing. A metric machinist ruler usually has at least two scales or sets of graduations. Each scale is located on a different edge of the steel strip. One edge shows millimeters for its smallest graduation, and the other edge shows half millimeters. Either edge of the rule can be used to measure. The 1 millimeter scale is easier for use for quick measurement, but it is not as precise as the 0.5 millimeter scale. Determine the smallest dimension that can be measured. So looking at our rule, we can see that this side is 0.5 millimeters and this side is 1 millimeters or millimeter scale. So our smallest graduation for this particular rule is going to be 0.5 millimeters. That would be 0.5 millimeters. So determine the largest dimension that can be measured. So once again, looking all the way over to this side, we can see that the last number we have on this is 140 millimeters. But it actually goes past that to 150 millimeters. So our scale reads from 0.5 millimeters all the way to 150 millimeters. In this exercise, we're going to determine whether the rule is bent, curved, or twisted. Each edge of the rule should be straight. It should not be bent, curved, or twisted. Inspect the rule for damage such as chips, cracks, cuts, or heat stains. Damage can cause the rule's graduations to be unreliable. So here we have two examples of the same rule. This rule right here, the way that I like to start is I like to touch one end just to check. I call this the rock test to see if the rule rocks at all. My table is flat and it's known flat, so that's where I start. Then I'll actually roll it up on the side and I'll physically look at it from the top to see if I get any, bends or warps, and I don't see anything on this one. Lastly, I'll flip it up like this and I'll look down it to see if I get any torque or anything like that on the rule. Once again, this one looks great. Looking at the face of this rule, you can see that there is no color distortion other than where the fingerprints are. No chips or anything missing from them. So this one is good to go into service. Looking at the next rule, this one right here, we're going to do the same thing where we're going to physically touch one end, and we can actually see where this one lifts up. So it lifts up so much that you can actually slide this rule underneath it. So this rule is actually warped. And you can see that if you roll it up on the end, you can actually see that there's a bend in this rule. So this rule I would not use for any precise measurement. You should always check the calibration of a new or unfamiliar measuring device, unless your company has already determined that it is in calibration. This step uses the straight edge as a standard for the calibration, but measurement devices used for quality control purposes use qualified standards for calibration. A standard is a physical object of reference used for comparison to a measurement system by a measurement device. To be considered a qualified standard, a responsible party must confirm that the object is an accurate and precise representation of the reference measurement. For the first step, we're going to lay the machinist ruler and the straight edge down on a flat surface so that the machinist rule's 0.5 millimeter graduations are alongside the metric graduation of the straight edge. So we're going to put this down right here to start with. Align the machinist rule's 10 millimeter mark with the 10 centimeter mark of the straight edge. So then I'm going to take it. Here's my 10 millimeter mark, and here is my 10 centimeter mark. Then we're going to look at the zero end of the machinist ruler to see how its short edge aligns with the 9 centimeter mark on the straight edge. The end of the machinist ruler should line up precisely with the straight edge's graduation. So we're going to look here, and as we can see, this lines up precisely with the 9 centimeter mark on the straight edge. So our rule are in calibration. In this exercise, we will be measuring the length of a standoff in the polish and wheel drive assembly of the Skill Boss trainer using the 1 millimeter scale on the machinist rule. Stand the machinist rule on its end and position the rule in line to the left of the standoff. When measuring, make sure that your rule is flat up against your standoff or whatever it is you're measuring. So it should look something like this. Not like this or this, just like that, to where it's flat across. You shouldn't see any air or light between the two. Taking this measurement, we can see that our graduations go 10, 20, 30, 40. So our major graduation of 40, the standoff doesn't make it to 50, so we know it's going to be 40 something millimeters. And then we can count those off, and we can see that there's around 3 millimeters past that. So our standoff's actual length is 43 millimeters. To understand how to read the rule, let's first look at the graduations arrangement on the scale. You may notice that some graduations are longer than others, but the distance between any two side-by-side graduations is exactly 1 millimeter on the millimeter scale. These different lengths are used to help you determine at which mark you are looking at. The longest graduations on the rule are placed every 10 millimeters, so 10, 20, 30, 40, and so on. Between each of these graduations are the 1 millimeter graduations. Each graduation or mark identifies a length from, for instance, on the 70, 71 to 79 millimeters, with the midpoint mark identifying the 75 millimeter mark. The midpoint mark, or the 75 mark, on this particular rule are the second longest marks. So any of the fives, so 15, 25, 35, 45, 55, 65, 75, and so on. Those are the second longest marks on the rule. The 1 millimeter scale is read by first finding the 1 millimeter mark closest to the edge of the object, referred to as the 0 point. This is called the 0 point right here. If the measuring point is between major graduations, example 10, 20, 30, 40, add the nearest major graduation on the left to the number of graduations nearest the measuring line. So here's our measuring line. This is basically what we're measuring. We're measuring this block. So looking at our major graduations, 10, 20, 30, and we see that our block measurement goes past the 30, and then we count our millimeters past. So looking at this, we can see that it ends right here, so it would be 30, and we're going to add the 1, so it's 31 millimeters. So this block, its measurement is 31 millimeters.